So instead of doing it frequent in every 6 months, this predictive solution can guide you that so that service or maintenance can be done after 1 year also. Now, decarbonize means we have to move from brown power to green power. So it can be electrify the operations, the processes can be con, moved to electrified operations, then reduce the energy use. So there are processes in every manufacturing plant. So these processes, then usage of power can be reduced by energy management solutions, and energy source can be replaced with solar, installation of solar, renewable, everything, and entire value chain can be engaged to decarbonize. And we as a Schneider Electric, we give solutions, and we can be a partner for the entire ecosystem. So these are the products in the right side. So scope 1, 2, 3, I've already told. And now decarbonization roadmap I have discussed. Now ecosystem is a solution which talks about all this sensorization, digitization, all these things. And coming to this SF6 free technology and the equipments, I will come to it later. Now, define the climate strategy. So first step is strategize, going into deep. So first we have to measure. So measure the carbon emission, how much we are emitting. There are different ways of measuring CO2 emissions. So we do that. Then we decide we finalize a decarbonization roadmap for the organizations based on their the data. Now after that, how the organization can reach the 1.5-degree trajectory, which is set by the as a global target to reduce the temperature increase of temperature. So that how this can be achieved, what should be the steps, what should be the processes, where the optimization, all these things can be done, can be guided by us. Now structuring. So we have to do this measurement, then creating a roadmap, then the structure, strategize, governance. So how this power can be arranged, which source can be used for power, all these things can be structured by us. Then we can communicate. And finally, we help to generate a report, and this report can be published by the organization, so that based on this report, this uh, ranking of sustainability and where we are, those can be understood. Now digitize. So I have already told how this equipments can be made digital, and this can be monitored from a remote location also. So monitoring of the equipment, its health helps in reducing this energy usage and any CO2 emission. Now identifying opportunity for emission and cost reduction. So we help in cost reduction also. Now report preparation is a part of our activity which we can do for our customer, for different organizations. Now coming to the step 3. Step 3 is to execute your decarbonization strategy. So the strategy we have decided and communicated to you. Now it is time to execute the decarbonization strategy using 4 key pillars, that is electrify, reduce, replace, and engage. Electrifying operations includes mobility, industry, and building processes. So reducing energy use involves digitization, efficiency, and optimization. Replacing energy sources means integrated sourcing, renewable, and carbon credits. Engaging the value chain includes supplier decarbonization and circularity. Design and build the sustainability to maximize the impact. And we are there to support you as a partner for all these steps, to execute all these steps. Now, coming to a video. Let's see the video.
In an age of fire. Since harnessing its power, it has fueled our evolution, but it came at a cost. It's time to decarbonize. It's time to evolve to a new electric world. It's time for a change of mentality. Let's look at electricity through a digital lens and let them bring out the best in each other. When electric meets digital, it gives us new ways of thinking about it, new ways of distributing it, new ways of saving it. Energy becomes connected, smarter, and more controlled. It becomes electricity 4.0. Electricity 4.0 works for you and with you. It delivers more and wastes less. It helps companies and individuals operate more efficiently, more successfully. It helps our planet become more resilient. A new, all-electric, all-digital world. The future is simply electricity for zero. Zero waste, zero emissions, zero carbon. Electricity 4.0.
So as of now, we are in this phase that electricity 4.0 is there. So now, as we talked, that SF6 is a gas, which is a greenhouse gas. So we have to come out from this SF6 usage. So this ring main unit you must have seen on the roads, installed by WBSCDCL or any utility like be it in other state also, everywhere. So these ring main units are used in on roads for giving power supply, 11 kV power supply to different areas and domestic purposes and everywhere. So to decarbonize the electrical system, we need SF6 free switchgear. So the innovation is in SF6 gas. This gas needs to be made CO2 free. So for that, we have already come out with pure gas. So why this SF6 is a greenhouse gas? Coming to that, this one RMU I have shown you. This is a three-way RMU. One is incomer, another is outgoing to the next RMU, and middle one is feeding to the local transformer 11 kV by 415. Then this 415 volt is supplied to the domestic use for domestic use. So this RMU concept you must be knowing. Now this total greenhouse gas emissions out of this is 80% is contributed for this energy production and consumption. So as per Kyoto Protocol, the six greenhouse gases are these six CO2, CH4, N2O, HFCs, PFCs, and SF6, sulfur hexafluoride. These SF6 is used for switch gears, 33 kV to 765 kV. All these ranges are having this SF6. We have to slowly come out from this SF6 technology, and we are ready with pure air for our 33 kV equipments. We are not there beyond 33 kV, so up to 33 kV, 33 kV and 11 kV RMU also, we have come up with a substitute of SF6, that is pure air. So why this SF6 is toxic? It is if and every RMU have almost 3.5 to 4 kg of SF6. That means 1 kg of 1 kg SF6, if it is released in air, that means 24,300 kg of CO2. This is equivalent to 1 lakh kilometer of a car running and 12 to and fro journey of a flight from Europe to India. So you can imagine the quantum of CO2 is equivalent that of 1 kg SF6. So if there is no policy exist for this sustainability, So the temperature increase will be 4.1 to 4.8 degrees C. And as per current policy, it is 3.7. So we have to move faster, and we have to meet the target of 1.5 degrees C by 2100. Okay. This is vacuum interrupter. This vacuum interrupter is so this is vacuum interrupter. This vacuum interrupter is kept within SF6. So this is the technology, and at present, this SF6 technology has been used because there was no substitute. So it's very good medium for breaking an electric arc, because this arcing is happening within this SF6, so it breaks the electric arc. So it's a very good medium, and it's reliable since so many years these are being used. And it's the if a 33 kV switchboard of 1250 ampere, it takes almost 1000 width. So instead of if air insulated switch gears, if we use SF6, the space becomes half. It's almost 600 within 600 we can place a 33 kV switchboard. So its space is costly, so we can save space by using SF6 technology. So we have to slowly come out from this SF6, and now this pure air which we have come up with also comes within this 600 So there is no compromisation on space. Now we have to move out slowly from this SF6 technology. Annually, SF6 emission is equal to uh, equal CO2 emission of 100 million cars. Now coming to this braking technology. Okay, so just a minute. So as per this global policies differently taken by different countries, so China is going to be SF6 free. So they have already taken a pledge or internal targets. Now European Commission have finalized a date that from 1st January 26 onwards, they will impose to come out from this SF6 technology. California, they have already restricted acquiring new SF6 equipment. So in India, it has not still been implemented, but it will be implemented soon, maybe within a year or 2 year or 3 years. This will be implemented. So now the impact of SF6 in the power sector, India power sector is very much significant. I will share some data taken globally. So India uses around 250 tons of SF6 annually, with 3,000 tons of install base, which is equivalent to 6 million ton of CO2 emission each year. So every year we are emitting 6 million ton of CO2. So these are the contributions from power sectors. And distribution networks are responsible for majority of SX emissions. Immediately actions are needed. So minimize the leakage, monitor emissions. So if there is a equipment, be be it a stainless steel tank, within stainless steel tank, this SF6 is kept, and this interruption happens within this stainless steel tank. Still, there are leakages. As per IC guidelines, there should be the leakages should be restricted to 0.1% per annum. So j- so there are leakages happens. So these leakages uh, should be arrested immediately, and SS6 free equipment is urgently required to be introduced to reduce the environmental impact. So India government also should take initiatives, and they should take targets, or they should issue some regulations so that this SF6 technology can be uh, moved away from market. And Schneider Electric is a organization who is a advanced technology supplier and is handling this programs very efficiently. Now, so what action we should take? We should immediately take action so that we can move out from SF6 contained equipments. So these are the equipments where these SF6 are used. You must have seen modular type of switch gears where SF6 is used, ring main units 11 kV RMUs, and primary switch gears are like that 11 kV and 33 kV gas insulated switch gears. Okay, so this gas insulated switch gear, if you see the construction here, this is the tank where this SF6 is the SF6 filled tank are kept, and this is the portion where the bus bars runs from one panel to another. These are the horizontal bus bar. These are the bus bars. These are also kept within SF6 tank. Here there is an isolator. So this isolator isolates this breaker with the bus bar. So this bus bar is in SF6 enclosure. Bus isolator is in SF6 enclosure, and this is the vacuum interrupter which I have shown in white color earlier. So this is also kept within the SF6 enclosure. So this is gas insulated switch gear, 11 kV and 33 kV. These are called primary switch gears. This is ring main unit. Here, in this case, this is single unit of panel, and another panel can be added on right side, left side. So there can be series of panels, 10 panels, 12 panels, 15 panels, any combinations it can be. And this is, and every panel have separate bus bar chamber, every panel have separate breaker chamber. This is the mechanism. I'm just telling you to understand what are the products. You become familiar with the products where this 33 kV equipments are there. So this is the numerical relay. This is the typical photograph of a 33 kV gas insulated switchgear. This is 11 kV ring main unit. This can be seen by you in on roads. So there are three units. Everywhere there are circuit breakers. So here there is a circuit breaker. This can be isolator or circuit breaker. These two can be isolator or circuit breaker. There can be any combination: two isolator, one circuit breaker, or two circuit breaker, one isolator. Any combinations it can be. And this is the tank here, and this is a throughout end to end. There is a single tank. So ring main unit comes within single tank, and this gas insulated switchgear panels come in different separate tanks. This is the difference between ring main unit and switchgear 33 kV gas insulated switchgear panels. So here what happens, this it's a ring main unit. Why it is a ring main unit? So similar type of equipments are installed at a distance, like at a 1 kilometer distance can be, maybe, or 500 meter, maybe every 500 meter there can be a ring main unit. So from here the cable will come, and it will go to the another ring main unit, like similar equipment if it is there. So from previous one to here and here to there, and the middle one will give the supply to the local transformer. So this is the concept of ring main unit. These are primary switch gears and these are modular switch gears. So now we will see how these ring main units can contribute towards sustainability. As on date, all the ring main units in India, it's conventional. There's so it is the parts are not reusable. Recycling is not possible. Those are not digital. The asset health cannot be monitored. So some many time flashover happens, and we used to face load shedding and all. So we will share I will share a video of ring main unit, how this can contribute towards sustainability. If you own this equipment in your network, means uh, this will definitely be taken by WBSC diesel or any government or private utility, maybe in Tata Power and other districts, Adani, whosoever is CESC can be. So this equipment should be made digital to reduce and energy efficient. It needs to be made energy efficient by and the raw material should be used green premium products. So all these things can be done, but it comes at a cost. So yes, this can be the future. This is the future. So let's see the ring main unit video.
Introducing RM AirSet, the new SF6-free gas-insulated switchgear and ring main unit, designed for enhanced safety and sustainability. It's powered by pure air, with shunt vacuum interruption. It's powered by pure air.
See, these are the cable terminations. This is the tank. So here, all the interruptions are happening. The vacuum interrupter, that is VI, is there within this chambers. These are the cable terminations. From here, cable is coming, power is coming. From this side, the power is feeding to the next RMU, and from from this side, sorry, and from middle chamber, the power is feeding to the local transformer. From local transformer, it is the 11 kV by 415 volt transformers are there. So those transformers are feeding power to our uh, as per our requirement.
Introducing RM Air, with shunt vacuum interruption and no gas recycling for a lower total cost of ownership. Featuring maximum flexibility in a compact package with powerful internal arc performance and optimized maintenance, with components insulated in a sealed tank to withstand harsh environments, built with high-tech composite materials for up to 10,000 operations and a 40-year life expectancy.
Yes.
Introducing environments, transition, with plug-and-play motorization, composite materials for up to 10,000 operations and a 40-year life expectancy.
So life for this equipment has also increased. So previously, this RMU life was 30 years. Now it has become 40 years.
From simple monitoring,
These are the sensors mounted.
capabilities. Innovative yet familiar, retaining the three-position switch and compact design. Take the next step toward a decarbonized, future-ready grid with RM AirSet, powered by air and digital.
So this product is designed to have sustainability, safety, and efficiency. Mm. So this new design and the ring main unit is a purely digital and manufactured with green premium components, and designed for medium voltage secondary distribution network that it offers sustainability, efficiency, and safety. So this ring main unit is used for connecting, isolating, and protecting transformers and feeders. As I have already told, it's suitable for both ring and radial network configuration. The use of air insulation makes it safer and more environment friendly, since we, instead of SF6, we are using uh, pure air. It's environment friendly, and digital features which are added to this product gives enhances the performance and continuous monitoring of your electrical assets. So continuous monitoring helps in reducing incidents like flashovers, and it's a kind of tool which help you to for proper maintenance and predictive, rather it can be predictive maintenance. And this innovation have set a new standard of the medical for medium voltage distribution. So as we are into this equipment manufacturing organization like us, there are other organizations also who have come up with similar kind of technology for their products. So market is fully ready to own this new technology, to adopt this new technology. Now coming to the sustainability index for this product. So this ring main unit is designed with sustainability, keeping sustainability in mind, achieving up to 93% recyclability of at the end of its life. So after using this product for 40 years, the 93% of the parts or portions of this ring main unit can be recycled. So it's helping you to reduce carbon footprint, to enhance efficiency, and maintain to achieve your sustainability parameters. So to protect this and to avoid this greenhouse gas production, the life cycle has been made for 40 years, and this in turn is reducing the environment impact. Pure air insulation means zero global warming potential. The global warming potential is zero for this pure air, and no harmful byproducts. So the sustainability index is verified by third party certification, ensuring transparency and credibility. And we also use tools like CO2 calculator, which helps in measuring and optimizing the environmental impact. This RMU design philosophy is about maximizing value while minimizing waste. So if some customers or this utility, government utilities or private utilities can opt for this solution, then it will contribute to a circular economy and a healthier planet. Now, this is previously I was discussing with regarding ring main unit. Now this is gas insulated switchgears. So as I have already explained, this gas insulated switchgear, this is the breaker mechanism. This is numerical relay or LV chamber, and at back there is a SF6 tank, and here the busbar chamber is there. So this is also a product where we have come up with innovative solutions, and eliminating this SF6, we have come up with pure air. Now let us see the video.
Is sustainable and will come from many different renewable sources. This means the number of operations switchgear has to perform will grow dramatically. The innovative combo drive operating mechanism takes switchgear mechanical endurance to a whole new level. In a world's first with an MV switchgear, combo drive is built from composite materials, an already proven technology in automotive and aviation industries. Its creation follows years of laboratory research to select robust materials designed to resist mechanical shock and wear experienced throughout its 40-year expected life, and up to 10,000 operations with rigorous endurance testing completed to ensure compliance with IEC standards. Compo Drive is available in our sustainable MRSET and SMRSET MV switchgear ranges, with a range of upgrades, kits, and tutorials available. The drive can be easily upgraded in just 15 minutes without the need to de-energize the switchgear, resulting in less operational disturbances, with enhancements such as plug-and-play motors available to enable remote operation. Maintenance requirements are also greatly reduced, as the durable materials will not corrode through harsh environments, and the lifetime lubrication helps deliver added peace of mind. Seamless integration with the familiar 3-position switch helps reduce operational risk, ensuring the switchgear can only be connected to one of the 3 positions, with the visual representation enhancing operator safety. Operation of the switch disconnector and earthing switch is done easily, with an inbuilt interlocking feature. The Compo Drive mechanisms offer greater performance and endurance in our switchgear ranges, powered by air and digital. A reliable and innovative solution in all environmental conditions, the recyclable Compo Drive helps you meet sustainability targets.
Okay, so we have now seen the products which are contributing towards sustainability journey of the users. So CO2 emission has been drastically reduced if we are using this technology of SF6 free switchgears. Now we have conventional switchgears at our premises now. At present, we are using 33 kV switchgears, 11 kV switchgears, or transformers, many equipments in our premises. So these equipments are installed maybe 10 years, 20 years back. So these all are conventional. So what is happening inside, we do not know. So this equipment can be made digital, and the new technology switchgears also comes with digitization. So how this is done? So I will just explain this sheet here. The sensors are mounted inside panels within breaker chamber, within busbar chamber, and within hot joints, and those are temperature sensors. And another sensor, that is ambient sensors. Ambient sensors are also can be mentioned, which measures the moisture of that particular area. So if there is moisture, that can be monitored. If moisture level goes high or goes above the set limit, so we can immediately bring our attention to attend the switchgear for predictive maintenance, or we need to send manpower to have a look what is happening and why this temperature is getting increased, or why this ambient moisture level is getting increased. So if we immediately send manpower to that portion, so we can avoid any unwanted flashover or unwanted downtime. Similarly for transformers also. Okay, then for this is communicating to a centrally located SCADA or some dashboard, where this 24/7 the data are fetched, and this it will give alarm, it will give indication, it can send SMS also. One more thing we are doing, like these all are critical equipments. It has a critical control scheme drawings, like there are wirings, there are a bunch of wires. So these drawings are, till now it is in hard copy. So, and soft copy are also there, but everyone prefers to use hard copy. So there, if you made this switch gears digital, so there are certain barcodes which we mount on the door of this equipment, and if we scan that barcode, it will show you the entire drawing, then catalog of the equipments which are used in the switchgear, and troubleshooting videos also are shown, and equipment location, everything can be fetched from this barcode. So this is one way of making it digital, using less paper keeping with instead of keeping hard copy drawings and manuals, we can make it digital, and we in fingertips after scanning this barcode we can have a look of the entire schematic drawings, manuals, catalogs, everything. So it's very helpful, and this data is fetched sent to the cloud, and in cloud our experts are there, and if you are not seeing this data, or if you are unable to monitor, our team is there who is sitting 24 by 7, and they can guide you, that if there is some abnormality seen by our team, they will make phone call, they will send SMS, and they will inform you to have a look of the equipment. So this way also we are contributing to the nation, to the country, to reduce carbon footprint. So these are the ways where we can help reduce this flashovers also. So it's this way we are monitoring and managing the switchgear equipments at every level. So the middle, the first, we are seeing that how can we directly see the data and monitor the equipment from our smartphone or laptop or PCs. That by nearby thermal monitoring, the sensors senses the temperatures, and feeds the data to our mobile or smartphones or laptops. And the center one, it's a local monitoring through HMI SCADA. The data is fed to the SCADA, and it's the SCADA enables local condition monitoring, giving operators details and real-time insights right at the control room from the site. And on the right side, we see the power of cloud connectivity. Data from switchgear can be sent to the cloud, where advanced applications, analytics, providers, and smart alarming and deeper analysis are happening. This enables remote monitoring, predictive maintenance, and access to expert support from anywhere. Similarly, the digitization brings a flexibility and intelligence to the switchgear management. Whether you are on site or in the control room or assessing insights from the cloud, this multi-layered approach helps for maintaining safety, reliability, and efficiency, making the operations of the equipments smarter and more responsive than ever in previous time. And similarly for transformers also, for every equipment, for home also we have solutions to make it smart home. The lights and fans and other equipments can be managed and can be energy efficient, can be managed or can be operated in an energy efficient way. So smart home solutions are also there. So, and for transformer also there are a technology which is called EcoStruxure Transformer Expert. What we do, we put a sensor at the oil inlet valve of the transformer. These sensors are connected or inserted to the oil for at least 10 mm or 12 mm area. So this sensor continuously monitors the oil characteristics, and if there is formation of H2 or ethane or methane in the oil itself due to arcing or something, so this data will be directly fed to the cloud, and our experts are there 24/7. They will monitor, and the similar data will be fed to your laptop, your PC also. This sensor also monitors hydrogen. There is additional part of that sensor probe, which also senses H2. This H2 sensors and this oil sensors can be mounted in transformers, so that you can continuously monitor 24/7, monitor the transformers. Then temperature sensor, humidity sensor, PD sensor, all these things can be mounted to a transformer. If it is a big 50 MVA transformer, 80 MVA transformer, 100 MVA transformer, so this solution can help you to protect your transformer for unwanted downtime. If a 50 MVA or 100 MVA transformer fails, to rectify the transformer, you have to send this entire transformer to the warehouse or manufacturer's place or at some place, and this rectification of this transformer, it takes at least 1 month or 1.5 month, 2 months time. So during that period of time, the production loss amounts to a huge. So this amount can be saved if we use this ecostructure transformer expert. Similarly, this for panels, it is called ecostructure asset advisor. So these are ecostructure solution. So coming to end, our purpose is to empower everyone to make the most of energy and resources, bringing progresses and sustainability for all. So by working together with us as a partner, we can ensure that progress benefits everyone and all stakeholders and everywhere. So this is the last slide. So sustainability is like a marathon and without a finish line. It's all about raising the bar and going at it again. As mentioned earlier, we simply cannot afford to meet minimum requirements, not to leave anyone behind. It's all about the culture and the strategy of going beyond the scope of expectation. Let's discuss how can we support organization sustainability ambitions. So uh, it's open for you now. These are the solution where Snyder is working, and can be a partner for your organization, for the industry, for any sector and every sector. And we are happy to accept or understand or listen for any kind of problems you are facing in your plant, in your uh, manufacturing unit or processes. So we can give solutions so that energy can be used in an efficient way, and you can reduce your carbon emissions. Thank you. That's all from my side.
Thank you, sir.
Yeah.
Participants, if you have any questions regarding the topic, you can ask our speaker, sir. Okay, I don't think they have any question, because the uh, session was really uh, very nice. So, coming to an end, I would like to thank you, sir, for giving your valuable time from your busy schedule and delivering such an engaging session. Sir, here is a small note of appreciation for you from our side. Please accept it. And
Yeah.
if you can, if it is visible.
Yeah, it's visible now.
Okay, sir. Uh, Thank you. And we are looking forward to learn some more from you in near future. And thank you once again. And
Yeah.
have a good night, sir.
Okay.
Thank
So just a minute. This certificate, I need to take a photograph or what?
No, we will be sending it over mail to you.
Okay, right. Thank you, sir. Thank you. Thanks a lot.
Oh, thank you.
Okay, right. Sir, one more thing. This next session will be starting from 7:30, right?
Yes, sir.
Should I be a part of that program or
Yes,
no? I can leave it off.
sure, sir.
Okay.
You will be
I'll
a part.
try to join off late. I will leave from office now and I will try to join late. Okay, right. Thank you.
Okay,
I'll
okay, sir.
try to join. Thank you,
You
sir. Thank you. Thanks to
Okay,
everyone.
thank you.
Thank you, sir.
Thank you, sir.
Thanks a lot.
Participants, please stay connected because our next session is going to start from 7:30. So don't miss out anything. Stay connected. Thank you.
Participants, please stay with us. Our next speaker will be joining within 5 minutes.
Participants, please stay connected. Our next speaker is going to arrive very soon. Please have some patience and stay connected. Hello. Sir, am I audible?
Yes, sir, you are audible.
Our next speaker has already arrived. Alam sir, am I audible, sir? Sir, we can't hear you. Could you please? Okay, just a minute. Give me a time. I'll make you a co-host, sir. I'm making you a co-host. Is it? Mehboob Alam sir, am I audible to you?
Yes, you are audible. May I start?
If you want to check the connectivity and screen, you can go to, because yes,
Yes,
we are
yes.
still having uh, 5 minutes of time.
Okay, okay. Just I'm sharing my screen and you confirm that whether it is visible or not. Okay.
Yes, yes, sir, definitely.
Please confirm whether it is visible or not.
Yes, it is. It is visible, sir.
And my voice is clear.
Yes, your voice is clear too, sir.
Okay, good.
So if you can you slide the screen?
Yes, sure.
Sir, it is okay, sir.
Screen
It is-
is visible.
Yes, sir. Yes, sir. Okay, okay, sir. Okay, sir. It's all okay, sir. So let us start.
Should I keep my video on or it should be off?
That's up to you, sir.
Oh,
You can keep it on.
okay. So, first of all, I would like to extend my heartfelt gratitude to SSD and the organizing and the coordinators of this FDP program. My topic is energy conservation and energy management, and evident need for achieving energy ecosystem. This is a brief overview of my presentations that all these topics will be covered one by one. First, that gravity and the importance of energy efficiency and energy conservation will be discussed, keeping in mind that the government of India target as well as the global target. As we know that the different COP conference of parties has been organized, and now across the globe, our main target is to achieve net zero. Meaning that we have to cut the emission. We have to cut the emission to limit the global temperature rise. And to achieve that target, we have to adopt several initiatives. And one of the initiatives is energy conservation and or energy efficiency improvement. And what are the key barriers and and how we can achieve this conservation in our daily life, along with our different industry. Few industrial cases will be discussed also. And industry, that energy conservation programs can be carried out. Three cases will be discussed. The government initiatives and policy regulations will also be highlighted. Among them, the tax cycle is the prominent one, performance achieve and trade cycle, and there is certificate, meaning energy saving certificates, how it is being traded in the platforms, and finally the conclusions will be delivered. So the people
Sir,
yes.
before you go into deep, I would like to introduce you to our participants.
Oh, sure. You can introduce. You will introduce or I will introduce.
I will introduce you to our
Sure.
Our next speaker. Sir, we are very much honored that you have given us time for this session. Sir, I, Sudeep Kumar Bid, on behalf of our committee, would like to welcome you in this FDP session, day 3, session 2. So, sir, the session is yours now. You can start.
Thank you. So, thank you, Professor Bede, for the introduction. And also, I express my thanks to the organizers for giving me this opportunity to speak before the audience, right, and to share some of my ideas related to the topic. So, Professor Priyanka, madam, is she there? Just now she called me that whether I have joined or not. So, Professor Priyanka Datto, is she online or not?
Yes, sir, I'm here.
Okay, fine. All right. Okay, so can I start the presentation now?
Yes, sir.
Yes.
Okay.
Yes.
Okay, thank you. So let me share the screen. Just confirm that you are able to see the presentation. Right, so is it visible to you?
Yes, sir.
Okay. So just check whether the slide transition is taking place, right? So let me move one slide forward. So is the transition happening?
Yes, sir.
Okay, fine. Okay, so thank you. Thank you once again for inviting me and giving me this opportunity to present my session and to give the opportunity to interact with the participants. So I see quite a good number of participants, maybe more than 75 I found when I checked last time. So that is quite encouraging. Right? In such a late evening session, still 75 plus participant. So that is quite encouraging. So thank you all. So let us start. So the presentation topic is the grid integration of renewable energy, challenges and solutions. Now let us just talk a little bit about the renewable energy integration. So as we all know that we are gradually shifting towards these renewable sources, also known as the green sources of energy. So the fundamental thing is that our focus is to reduce the greenhouse gas emission, because we are all aware that the global temperature is on the rise. We are seeing climate change over the last few years. So it is high time that we do something to save the Mother Earth and the climate, right? Because if we continue to use the fossil fuel at the same rate that we are doing at present, then probably within a very short time, the planet will be unlivable. So we need to do something. We need to cut down our greenhouse gas emission drastically. And that is why the renewable energy sources are the solution. Now, the countries around the world, they are having very ambitious renewable energy targets, right? So all over the world, there is a clear shift from the traditional fossil fuel based power station towards the renewable energy based power. Now, India is also not behind, right? We are also in the same league. So we'll come to that. But apart from this greenhouse gas emission, which is no doubt a challenging issue, there are also other aspects which we cannot ignore. One of which is the increasing price of coal, gas, and oil. Right? So as we see that the prices are gradually on the rise. And not just that, there are very frequent price fluctuations. Nowadays, we know that there are a lot of geopolitical issues. Say, for example, if we purchase oil from Russia, then we may have some sanction over us imposed by the US. And so many equations, geopolitical equations, they come into play. So price fluctuation, all these geopolitical issues, these are also of concern, and that is why it is very essential that we become self-reliant, and our energy sustainability is a need of the hour. So the only way we can achieve that is by shifting towards the renewable form of energy, right? Because you know that our coal, gas, oil reserve, all these natural resources, we are not having much of them, right? So we are basically importers of oil, coal, and gas. So the only way we can achieve sustainable energy for the country and self-reliance is to shift towards the clean form or the renewable form of energy. Now, when we talk about the renewable form of energy, I said that the India is also not far behind. So our government is focusing on large-scale integration of renewable energy. And in fact, in the last report of the Ministry of New and Renewable Energy, MNRE, which was released in November 2024, last year, we have already crossed energy capacity of 200 gigawatt, right, from the renewable sources. So that is quite a commendable achievement, that we are already having 200 gigawatts of renewable energy generation. And now we are focusing to have 500 gigawatts of renewable energy generation by the year 2030. So quite an ambitious target, but the pace at which we are proceeding, it looks that we will be able to achieve this target. Now, when it comes to the integration of renewable energy, how it can be integrated to the existing grid, right? Because that is a point of concern. Now, fundamentally, there are three ways to do that. One is to integrate them in the low voltage distribution system, or in the medium voltage, which is the 6.6 kV or 11 kV system, or high voltage transmission system, which is 33 kV and beyond. Now, it all depends on what amount of renewable energy we wish to integrate to the existing power grid. So if it comes to, say, a small amount of power, maybe say in the range of few hundreds of kilowatt only, then we can go for the low voltage integration. You know that many rooftop solar plants, right, and small scale wind generation, etc., these can be integrated even in the distribution level, means 415 volt three-phase system. But as the amount of power increases, say maybe in the range of say 10 to 15 megawatt, 20 megawatt, like that, then obviously so much of power cannot be integrated at a level of 415 volt. Then we have to go to the level of 6.6 kV and 11 kV. Now, if we are talking about hundreds of megawatt or even gigawatt, because as you have seen that it's not a matter of megawatt nowadays, right? It's several hundreds of gigawatt. So much of power that can only be integrated when we talk about the high voltage grid. So we have to think of, say, 132 kV, 220 kV, 400 kV, or even beyond that. So much of high voltage integration becomes necessary. So that talking about the high voltage power grid, where we have to integrate our renewable energy sources. Now, we have already seen that the renewable energy has a lot of advantages, and basically this is the future of energy, right? It is the cleanest form of energy. It is the most economical form of energy, and this is the only way we can achieve our self-reliance in the production of energy. But this renewable energy integration, that comes with its own challenges and operational issues. So as engineers, as technical person, we need to focus on all these issues, and we have to overcome these issues so that we can have seamless integration of the renewable energy sources in the existing power grid. Now, what are the key challenges? So first of all, it should be known to many of you that a major problem or the issue with these renewable energy sources are basically their variable and intermittent nature. Right? So perhaps in the last 2 days of session, you may have come across these terminologies several number of times. So these are the key challenges when it comes to integration of renewable energy. One is the variable nature of the energy, and second is the intermittent nature of the energy. So why these forms of energy are said to be intermittent and variable? The reason being that these are basically the natural sources, right? And we do not have control over the nature. As you know that the solar generation, for example, we only have solar generation when we have the sun. So that means the solar generation will only be available during the daytime. It will not be available at night. And also the rate at which we can produce energy from our solar photovoltaic cells will be heavily dependent on the climatic condition. Say, for example, during the rainy season, when you have a cloud cover, then obviously the generation will drop. Similarly, during the winter months, particularly if you consider the northern part of the country, North India, there you have heavy fog, right, over the winter months, and therefore the rate of generation drastically reduces. So that is why there are a lot of variability. There are seasonal variability. There are even variation in a particular day, right, depending on the weather condition on that particular day. So there are a lot of unpredictability, right, lot of uncertainty and variable nature of the energy. Similarly, if you come to the, say, wind generation, there also the situation is more or less the same, right? Because you know that the wind turbines, they need basically a steady wind velocity to operate. And this velocity must be within a particular velocity band, right? That means not too low, not too high. So there is a specific band within which these wind generators can operate. So if the velocity falls below a certain threshold, the wind generators cannot operate. Similarly, if the wind velocity is too high, right? Suppose there is a, say, gust of wind, right? Or there is a storm. Then of course, it is unsafe to use the generator. So they have to be shut down. So that is why you need a steady flow of wind throughout the time, right, for the wind generators to operate. And that is not always available, right? So maybe some specific areas of the country, say for example, the coastal region, that may have steady wind velocity throughout the year. But not every part of the country has the same wind velocity throughout the year. And also, you know that there will be cyclones, right, and other weather conditions, because of which the wind generation again will be intermittent in nature. So that is why the variability and intermittency will be there, and we have to cope up with this. So what will be the impact of this variability and intermittency on the power generation and power grids operation? That we will discuss in details. Now, along with this, we also need to take into account the cost of integration. Just now we discussed that when it comes to bulk amount of electricity, it has to be integrated in the high voltage grid. And as we talk about the high voltage integration, then you will require a lot of costly equipment, converters, etc. And they will also be very expensive. And along with that, the frequency response and system stability issue also has to be taken into consideration. So these are the basic challenges. So this is just an illustration taken from Power Grid Corporation of India Limited, their bulletin. So typically what it shows that how the wind and solar generation, they behave, right, over time Now, if you look at the left-hand side diagram, it is basically showing the wind generation from multiple sources, right? And these sources are actually not concentrated in the same region. They are basically located in different geographies, different parts of the country. For example, Gujarat, Karnataka in the south, and Rajasthan, the far west. So basically different regions, and you can see that if you consider one particular day and take 24 hours, you see that there are a lot of variation in the wind generation, right? Because the wind velocity is bound to change, and accordingly the generation level will also change. But the good thing is that if we can spread our wind generators over different geographies at different geographical locations, and then take the aggregate of them, then the variance, right, and then this intermittency will be reduced by a large extent, right? So if you look at this individual graph, they show a lot of variability, but if you take the aggregate of all of them, then probably the rate of variation will be far less. The same thing is also true for solar generation, right? So if you have a large number of solar plants, say for example in one power plant, the variation of daily variation, hourly variation will be much more. But if you take the aggregate of large number of PV plants spread across the country, then the variation will be far less. So one way to at least reduce the variability and intermittency is to spread these sources at different geographic locations, and then this climatic change will have lesser impact, and the overall the aggregate power that we can obtain from them will be more or less, I mean, there will be less variation. Now, along with this intermittent and variable nature, we also need to take into consideration that our traditional electrical power grid is basically designed for a steady generation, right? Because so far we were predominantly dependent on the fossil fuel based power generation, and therefore the generation was more or less steady throughout the day or throughout the month or throughout the year. So that is the thing, that it was more or less steady. And secondly, what is very important is that electricity is such a commodity which you cannot store in bulk quantity, right? It should be clear that we can have small amount of storage of electricity in the form of, say, battery storage or other forms, but that will only be limited to, say, maybe say hundreds of kilowatts, not more than that, because the cost will be prohibitively high, right? So if you consider large scale storage of power, then it will be very expensive proposition. So we can only have small amount of generation as a reserve, and generally what is done is that all these fossil fuel based power stations, they can have some primary source of energy stored at site. Say for example, a coal based power plant, it can have some coal reserve, right? So every power plant generally have coal reserve for at least for few days to at least few weeks of reserve is there, so that in case there is some supply issue regarding the coal supply, etc., logistic issue, then at least for a week the generation can continue uninterrupted. Similarly, if you consider, say, the diesel generators or even the gas turbines, right, there also they have at least some amount of storage of the primary fuel, which is the coal or gas or oil, and these reserves actually serve the purpose that if you need to increase the generation suddenly, then this reserve come very effective, right? Now, our power grids or the whole power system, they basically operate on a principle of so-called demand response. So demand response basically means that, as we understand, that electricity cannot be stored in bulk quantity. So that is why the generation of electricity has to match with the demand. So if the consumer load demand goes up, generation has to be increased. If the demand goes down, the generation has to be reduced. So that is why it is called demand response. That basically means that the generation has to respond to the load demand, right? Or it has to match the demand of load. Now, as I said, that the so-called fossil fuel-based generation has the ability to respond to the demand, right? So we can have some amount of fuel storage so that if there is a sudden increase in load demand, we can say release some excess energy and can produce more power. If you even talk about, say, the hydel generation, you know that we can have, say, large water reservoir or dam. We can have sufficient amount of water storage. So if there is a sudden increase in the load demand, we can release some extra amount of water and then we can generate more, right? So we can very quickly respond to the load demand. So that is a very good thing because you know that the power system has to operate in an equilibrium. That means the load demand and the power generation, that has to be matched at all point of time. So this fossil fuel based generation and the hydel generation has the ability to follow the load demand or to respond to the load demand. And that is why we often call them dispatchable form of generation, right? So all our fossil fuel or even the hydel generation is basically a dispatchable form of generation. But now if you think the other way, that whether the renewable energy can be called a dispatchable form of generation or not, then the answer is no. Because the renewable energy, how much energy you can produce, is actually not in your hand, right? Because it's basically a nature's gift, right? And it is basically nature decided. So we cannot decide. So if I want, I cannot increase solar generation, right? Because it depends on how much solar insolation is available. The same is true for the wind also, right? So if you have the wind, you can generate. If you do not have the wind, you cannot generate. So that is why these renewable forms of energy, particularly the solar, wind, etc., they are often called non-dispatchable form of energy. So this is again another challenge. Another thing is that our existing power grids, or you can call the traditional electrical power system, they have been designed to work with synchronous generators. We know that the synchronous generators are the main powerhouse, right? So they are basically the producers of electricity. And our systems, our existing grid, have thousands of such large synchronous generators spread all over the country, right? And they basically operate at 50 hertz. There is a common grid frequency all over the country. In US, the frequency is 60 hertz. But the thing is that they work in synchronism. So all the generators, they work at the same frequency. Now, on the contrary, if you come to the characteristic of the renewable energy sources, the situation is actually very different. So we have talked about volatility and intermittent nature. And we also said that basically it's non-dispatchable form of energy, right? So they can only produce power when there are adequate amount of sun and wind present. So they do not naturally have on-site energy storage. So that is a challenging issue, right? This non-dispatchable form of energy poses a lot of problems. In fact, you should be aware, particularly the power system people may have the idea that synchronous generators, they are gifted with an unique capability, which is the rotational inertia. You know that the synchronous machine's rotor is basically a huge rotating mass, right? So it's thousands of kilograms of weight and running at a very high speed, usually 3000 RPM. So they have lot of running inertia, right? Which is basically the half j omega square. And this inertia or the stored energy, that plays a very, very vital role in maintaining the stability of the system. Now, why it is so? Because suppose if there is a sudden change in the load demand, you know that the generation cannot be immediately increased, right? Because every power plant has its own time constant. So the boiler has its time constant, the turbine has its time constant, right? The fuel supply system has its own time constant. So it takes time to boost the generation. So it's not that if we have an increased demand, we can immediately boost our generation to match the demand. So at least momentarily, there will be a mismatch between the demand and the generation. And what this will lead to? It will lead to an immediate slowdown of the rotor of the synchronous generators. And that is why the frequency will have a tendency to drop. So this is quite noticeable that if you have a sudden increase in demand, the frequency will have a tendency to drop. So how do we cope up with the situation? We cope up with the situation by, say, opening the steam governor, right? Opening the, say, the idle power plants, say, the valve, right? So that more water can pass to the penstock. But that takes time. So the response time of these governors, valves, etc., that is again maybe quite large, right? Because these are basically mechanical devices having larger time constant. So what comes to the rescue then? It is basically the stored energy in the rotational mass of the synchronous generator. So immediately, that large amount of energy which was stored as half j omega squared in the rotating mass of the synchronous machine's rotor, that energy will immediately be released, and that will make up that deficit of power, right? And that is why the impact on the system frequency is far less when it comes to synchronous generator. So this comes as God gifted, right? So we are fortunate. The grid operator finds it very easy to cope up with a sudden fluctuation in the load demand, because the synchronous generator's inertia, stored energy, automatically takes care of that. Now the question is, when we talk about integrating bulk amount of renewable energy, can these renewable energy sources or the renewable generators will have the same inertia and the same characteristic? The answer is a clear no, because you know that this solar photovoltaic system, they basically use generally an inverter, right? Because they produce DC electricity and then it is converted to AC, 50 hertz AC by means of an inverter. Similarly, if you come to wind turbines, generally they use some sort of asynchronous generator, right? And that is why they also require some sort of power electronic converter to convert this asynchronous rotation of the turbine to ultimately produce a 50 hertz output. So all we see is that they basically require some sort of an inverter or converter, which are nothing but some power electronic devices or interface, and they lack the inertia that a traditional synchronous generator normally has. So that is quite a challenge, right? Because this is one fundamental limitation of these inverter-based system, which lack the natural inertia. So nowadays, we talk about synthetic inertia, and somehow we try to simulate or synthesize the inertia into these converters and inverters so that they can replicate the characteristic of a synchronous generator. So basically, this is what I said, that this inherent inertia of the large rotating mass of synchronous generator, that is quite beneficial because it can cope up with the voltage and frequency deviation. Inverters lack this advantage, and that is why we require some sort of synthetic inertia to mitigate the issue. So all that I have said so far can be expressed by a single terminology, which is called the transient stability issue. So as I said that the power system has to operate in an equilibrium condition, right? Which means that the load and the generation, they have to match. So normally when the system is operating steadily, you have a perfect matching between the generation and the load, right? And that is why the system is operating in a steady condition, producing a stable voltage and stable frequency. But suppose if there is a disturbance can come in many ways, right? There can be a power system fault. There can be a major contingency, for example, say tripping of a major power carrying line, say outage of a generator, say outage of a transformer, right? So these kind of things can happen, and that is why the system needs to cope up with these sudden disturbances, right? Now, obviously, the outage of a large generator, a transformer, or a transmission line will have significant impact on the power system. And the first thing that will be challenged is the rotor angle stability or transient stability of the system, and eventually the voltage stability can also be impacted, right? And also the frequency stability. So that is why we need to be very, very careful that the power system operates in a stable condition, which we often call secure condition of operation of a power system, right? And power system people, they should be knowing that we call it the power system security, that the system should operate in a secure condition. So all this discussion that we have made so far should make you should have a maybe that you should have a clear understanding that while renewable energy sources come with lot of benefits, but at the same time they also bring lot of new operational challenges and issues. So as power system operator or power system engineers, our key focus would be that how this power system's security issue or stability issue that can be taken care of, right? And one very popular mechanism, popular way to mitigate these issues is to use a very popular scheme which is commonly called as the system protection scheme. Now, system protection is not the power system protection that we often talk about in the traditional myths, right? So it is quite different. So that we will discuss over the course of time. So system protection scheme is a key enabler for secure operation of the modern power system. So let us see what is a system protection scheme is, how this can be beneficial, how this can overcome the security challenges. Now, system protection is also known as remedial action strategy, or in short, RAS. And this is basically an approach to detect abnormal system condition, which is typically contingency related. So just now I discussed what is contingency, right? It basically means, say, outage of a transmission line, outage of a generator, transformer, or any other major equipment. These are commonly termed as contingency. So contingency related abnormal conditions, they can be taken care of by this remedial action strategy or system protection. So what it basically does, that it basically initiates a pre-planned corrective action to mitigate the consequence of abnormal condition and restore secure operation of the system. That is by definition, right? That is what the system protection scheme means. So if we go by the definition, system protection scheme, or in short, SPS, usually refers to the collective actions which include collective measures like changing the load, generation, or even the system topology to maintain system stability, acceptable voltage level, and power flows. So this is the basic definition. So that means it is basically not a particular action, rather it's a collective action which primarily focuses on, say, changing the load or shifting the load, or sometimes even shading the load, then rescheduling the generation, changing the generation, and even system topology change, means say some sort of reconfiguring the system. So all these actions collectively leads to a scheme which is commonly termed as the system protection scheme. Now, IEEE uses the acronym System Integrity Protection Scheme, in short SIPS, whereas Western Electricity Coordination Council, WECC, they uses a term Remedial Action Scheme, or RAS, and rest of the world, including in our country, we call it SPS, or System Protection Scheme. So if we just go into further details of SPS, so System Protection Scheme, it basically came as a trade-off between investment, operational cost, and customer service quality. So this will become more clear as we go through the presentation. So they are basically attractive mechanism to enhance system performance, right? So performance of the system means in terms of stability, safety, and security. Right? So the key point is that they basically have a low cost or economical solution, right? And at the same time, they are also environmental friendly as compared to other alternatives. Other alternative means, say, commissioning new power plants, right? Having a new set of transmission line, right? Commissioning more number of generating station, which are basically very expensive proposition, and at the same time, they're not environmental friendly. So today, in many parts of the world, SPS represents a viable planning alternative than physically extending the transmission system's capability, and it is considered an useful tool to augment power systems reliability. So let us move forward, right? And then these terminologies will be further clear. So let us see what are the features and major components of the system protection scheme. So as I said at the very beginning, that system protection scheme is very different from the traditional power system protection. Right? When it comes to the power system protection, usually it comes to unit protection. Right? The unit protection means we have a dedicated protection scheme which is meant for protecting a particular power equipment, say a generator protection scheme, or say a transmission line protection scheme, or a transformer protection scheme. This is commonly called the unit protection. That means we are basically looking for some equipment protection. But system protection scheme is very different, right? It focuses on the power supply capability of the whole system. Right? So now we are not focusing on a particular equipment. Rather, we are focusing on the power supply capability of the whole system, right? So we have to take into consideration a lot of things, right? And basically the idea is to maintain a secure operation of the system and to maintain steady supply of power to the consumers. So what SPS generally includes? So typical components of the SPS includes, first of all, you need some measurement inputs. And generally the inputs come from SCADA, which is a supervisory control and data acquisition system. And nowadays, you know that we also use PMUs, phasor measurement units, also known as synchro phasors. They are gradually replacing SCADA, right? Because the PMUs, they basically provide you dynamic variables, like say the voltage angles, right? The generator rotor angle, etc. These measurements are possible with the PMU, which were earlier not possible with the SCADA. SCADA only used to give you the static variable, like say voltage magnitudes, say the power flow, right? Active and reactive power flow, frequency, all these data were available from SCADA. But nowadays with the integration of PMUs, we also have access to the dynamic variables. Second comes sensors. Sensors means basically we need to get the switch and breaker status, relay status, say whether the relay has operated or not, whether the breaker has opened or not, right? Whether breaker has closed or not. So this is called breaker status, switch status, and relay status. So some sort of sensor should be there which will transmit, which will detect this switch status and will transmit. Then, of course, we need circuit breakers because they are the main tripping equipment of the power system. We also require communication equipment because ultimately all this information first has to be communicated to the logic solver. The information has to come to the logic solver, which is basically the heart of the system. The logic solver will apply its own logic. Most of the time it's a rule-based system. We'll come to that later on. And then the logic solver's output, the logic solver will take a particular decision. And this decision ultimately has to be communicated to the actuating elements, right? Which will finally do some sort of, which will take some action. So communication is also important. And as I said, the heart of the system are basically the logic blocks, which will make all the necessary calculations. It will apply some if then else kind of logic, some predetermined set of rules. And on the basis of that, it will say take some particular decision and that decision will be communicated, right? So most of the time, the logic blocks are some sort of computing system, which may include a microprocessor. It can also be microcontroller, or it can even be a simple programmable logic controller. So this block diagram gives you some idea about the functional components of the so-called system protection scheme. So as you can see that basically if this is your power system, then you have the PMU or even maybe SCADA. So basically the SCADA and PMU will have the input measurements like voltage, current, frequency and all that. Now power system, as I said, it is prone to disturbance. So you can have disturbances like power system fault. It can be contingencies. So if the power system is subject to some sort of a disturbance, that will be recorded, that disturbance will be recorded by the PMU. And immediately, these measurements will be fed as input data to the decision block. So this is basically your logic block or decision-making block, where some sort of mathematical computation will be done, some logical decisions will be taken that what has to be done in the current situation to mitigate the problem. And then this decision will be communicated to the actuation block, which will take a particular corrective action. And this action will be applicable to